Hello and welcome to today's SEI webcast, Infrastructure as Code through Ansible. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our webcast today as interactive as possible, so you can add your questions to the YouTube chat area now. We will get to as many as we can. Our featured speaker today is Matthew Heckathorn. Matt is an integration engineer in the CERT division within the SEI, where he's responsible for assisting organizations in applying the DevOps process to their IT architecture. Welcome, Matt. Looking forward to the talk today. All yours.
Thanks, Shane. So, as Shane mentioned, I'm an integration engineer here at CERT, and today I'm going to be talking to you about infrastructure as code through Ansible. So, first things first, a little bit of sharing information here. But I find that it is often best with these kinds of discussions to define your terms first. So what is infrastructure as code? Infrastructure as code is this idea that you take representations of your computing systems, your data centers, and you turn them into machine-readable definition files. It's a method of lending automation to an area of work that didn't have as much automation. So rather than making use of a lot more manual processes for managing your physical hardware using your CLI tools, you instead turn those representations of how how your data center is provisioned and how it's configured into code. And you can then place that code in a version control system like Get. Doing so actually gives you the ability to make use of GitOps processes, which is a newer thing in the industry now. When you place your infrastructure as code in Get, you can leverage all kinds of benefits that Get brings. Things like code reviews, history, the ability to kind of go, history meaning the ability to go back in time, but also to kind of look at who made changes and when. And the other benefit of doing this, of turning your data center into code, is it allows you to leverage the DevOps process against your data center, right? So you can, against your infrastructure code, so you can plan and code and build and then test your code, release it, deploy it, operate it, and monitor it, and repeat over and over and over again. And it allows you to also leverage that philosophy against your infrastructure as well, which is a very powerful thing to do. So infrastructure as code, there's a wide landscape of tools now, and it's pretty easy to come up with a list of what the most popular ones are. So it's things like Chef, Puppet, Ansible, SaltStack, CloudFormation, and Terraform are some of the bigger players in this space. Some of these have fallen off in popularity as time has gone by, but these are still some of the biggest players. And each of these tools, they have different features, different use cases that they were designed for, which can make choosing them a little bit difficult. So what we can do is, in order to help alleviate the choice of a tool, we can look at what their tools are designed for and the trade-offs that we have to consider. So, for example, tools are broken up into a number of different categories. These are some of the major ones that you should consider when you're choosing a tool. Things like configuration management versus orchestration or provisioning, mutable infrastructure versus immutable infrastructure, procedural versus declarative, and client-server or master agent architecture versus client-only or master-only architecture. If we want to break out and choose a tool, we need to understand what each of these categories are. And I do need to call out that all of these categories are not necessarily mutually exclusive. Tools do not neatly fall into each bucket, but there are some tools that do one of these buckets better than others. And so we sort of slot them into those buckets. So for example, configuration management versus orchestration. Configuration management tools are really tools that if you've been working in this space for a while, they're the ones that allow you to configure, install, manage the software on existing servers, right? So these are tools like Puppet, Chef, Ansible, or SaltStack. Orchestration tools, those are tools that allow you to provision the servers themselves, and they oftentimes leave the job of configuring those servers to other tools, so things like Terraform or CloudFormation. Servers is sort of a generalized term here, right? We can use these tools to do serverless, all kinds of different things, right? But the idea is that one is the configuration tools designed around managing existing servers. They were really originally intended to do that. They might have taken on some features that allow them to provision servers or services now, and that's fine. Again, not mutually exclusive. It's just there's a better fit for those tools. Which brings us to mutable infrastructure versus immutable infrastructure. Now, mutable infrastructure is what you would think of as your classic data center. This is your old school iron. These are your servers that are put in place. They're continually updated and modified in place. These can also be things like long-running VMs, right? So these servers are mutable. They are changed after they're created, right? And there's benefits to this, right? And a lot of the tools, the configuration management tools sort of default to this paradigm, right? So tools like Chef, Puppet, Ansible, and SaltStack oftentimes default into this paradigm, or they were originally designed around this paradigm. One of the drawbacks of long-running infrastructure is things like configuration drift, right? So we put a server in place and we continually update it over time. Things might get changed that we aren't managing or that we're not aware about over time, which can lead to issues like security vulnerabilities or just issues with managing those servers when we go to tweak something and it doesn't work the way that we expect. Which brings us to immutable infrastructure, right? So immutable infrastructure is this idea that really was brought about because of containers. I mean, not entirely, but they're really the big thing that made this get pushed to the forefront. And this is the idea that servers or services are never really modified after they're deployed. If something needs updated, if the software inside the container or the service software needs updated or fixed or modified in any way, you build a new server or service or container from some common image and with your changes, and you trash the old one and create the new one in its place. And so that's immutable infrastructure. Now, again, I need to reiterate, each of these tools, they don't neatly fit into one of these buckets, but so tools like Ansible can manage containers and container lifecycles, but they were originally designed towards the mutable infrastructure. So that brings us to procedural versus declarative. So procedural programming, it's what you would think of as sort of a top to bottom, left to right list of, step by step how to do something, right? It's like a recipe, right? I start at the top, I go down line by line. This is how I'm going to configure my server, right? So tools like Chef and Ansible, they really kind of, this is the space that they operate in. Declarative programming is a little bit more, it's blurring the lines between a program as a set of instructions and this desired end state of the configuration, right? So tools like Terraform, CloudFormation, SaltStack, and Puppet fit nicer into this bucket. The example I like to use in this case, and this is a simple example, is let's imagine that you've deployed 10 servers, all right? And traffic has increased for your application that's running on those servers, and you want to increase the number of servers to 15. So with Ansible, and keeping in mind that Ansible falls under the procedural programming bucket, if you want to go from 15 or from 10 to 15, you update your number of servers variable from 10 to 15 and rerun your Ansible code. In the simple example here, Ansible would go and deploy 15 more servers, meaning you would have 25 total, right? Not your desired end state of 15. Okay, if you did the same thing in Terraform, you took your number of servers variable that equals 10 and updated it to 15 and reran your Terraform code, Terraform would take a look at the existing number of servers out there, because Terraform has this idea of state, and it would determine, okay, he wants 5 more. I'm going to only deploy 5 more, and you would end up with 15. So there are benefits and drawbacks to the way that to these two types of programming. I find procedural programming is a little bit easier to understand from the get-go, but it does have some gotchas. Which brings us to master agent architecture versus master only architecture. So master agent or client server, this is sort of a classic old school example where you have a master that's responsible for cataloging all of your infrastructure code and the nodes that you're going to manage. And in order for you to manage your nodes, they need to have an agent running on them, which can talk to the master. And it reaches out and asks the master for its configuration code, and then it configures itself, right? This has some positives. The nice thing is, bootstrapping a new node, you simply just drop an agent and instruct it to talk to the master, and it pulls down the configuration by itself, which is great. There are some downsides to this too, though. You need to run and install that extra software on every node or every server that you want to manage. You have to have an extra server or servers if you're running a cluster of them for high availability, just for configuration management. Those are your master or server nodes, right? So this would be things like your puppet master. And you not only have to install this extra software and hardware, but these are now long-running services that you have to maintain and upgrade, backup, monitor, and restore. So there are some downsides to it, but like I said, the upside is a new node comes up, it checks in, and it gets its configuration, and you're off to the races, right? So it can simplify things in some ways. Master-only architecture is where Ansible falls under, and this is where there are no agents running on the nodes, right? So what essentially what happens is Ansible or Terraform or whatever, they communicate to nodes or services via standard access methods. So, either through things like SSH or provider APIs. And oftentimes this leads to being easier to use and more maintainable for us as a user. The programmers of Ansible or Terraform need to keep up with API changes, but that's not our responsibility as a user of those tools. So our code is often a little bit easier to use and easier to maintain. So CloudFormation, Ansible, and Terraform, they're the ones that really lean into this master-only architecture. And this matrix here, right? So this just is kind of summarizing everything that I've described here and giving you an idea of where each of these tools fall from. I do need to call out that, the source for this is from a great blog from Gruntwork. And I actually, suggest that as some good reading on this topic. The Gruntwork blog is real good. But if you take a look at the Ansible column here, you can see that it falls under the configuration management type. It leans towards mutable infrastructure. It's a procedural programming language, and it's client only. So you don't have to worry about, setting up a master and maintaining it. So that's what we're going to focus on now. So we jump into Ansible. I don't know if we have any questions.
None yet, Matt. You can continue on. Yeah, we're good. Thank you.
All right. So getting started with Ansible then, right? So I've kind of highlighted what infrastructure as code is and how it can help you lean into GitOps and DevOps for your infrastructure. And I've sort of given you an idea of why you might choose Ansible for your infrastructure as code tool. So let's assume that you've done that. And how do you get started with using Ansible to manage your infrastructure? So that brings us to oftentimes you might start and figure out, well, how do I run Ansible and that kind of stuff? I prefer to highlight how you need to design and organize your top level playbook repo. And the reason for that is because if you don't do this correctly initially, it can lead to a lot of problems down the line. So first things first, hop over here and give you an idea of directory layout options, right? So Ansible has some great documentation on this. There are really two ways of laying out your directory. There's what I call the simpler way, which is this one. And then there's another way I'll go over in a second, which is a little bit more complicated, but can be good for more complicated data center or cloud setups. So at the top level of your Git repository, you'll have a set of files and folders. The top two items here on this directory layout, the one's called production and staging. These are your inventory files or host files, and I'll talk a little bit more about them in detail in a second, but essentially it's the list of nodes that you're going to be managing. And you can have as many of these as you want and name them whatever you want. It's good to come up with some kind of common naming thing, such as is shown here, production or staging. Under that, we have a couple folders, group vars and host vars. And these folders are used to assign variables to groups of nodes in your inventory file or host file. And so these groups here, so for example, if you had a group of nodes in production called AWS West, you could have a group, a file under group vars called AWS West.yml, and you could assign variables to that group there, and they would get those variables when you run your Ansible plays or your rules. Host vars allows you to do that on the host level, and there is an order or a precedence here, a variable precedence that you can look up. But essentially, host vars would take over group vars in this case. So if you assigned, a node to AWS West, and you gave it some variables in groups, and then you wanted to override a specific thing for one of those nodes in that group, you could do that in a host name variable here. There's also some folders here for customizations for Ansible, things like library, module utils, and filter plugins. Don't really need to rely on those too much or even really include them unless you're doing a bunch of custom work. So oftentimes I tend to ignore them and I haven't used them too much. The other thing is after that, we see a list of 3 playbooks here, the .yml files, the site.yml, web servers, and DB servers. So these are just various playbooks at the top level that do different things. Oftentimes it's good to give them a descriptive name. So web servers.yml probably configures web servers. Site.yml probably configures your entire site, right? It can be named whatever you want, but for a human that's taking a look at this, it helps to stick to something descriptive and simple. So that leads to roles, the roles folder. Roles are really how you do everything in Ansible. While you can do things with tasks, roles are a great way of creating shareable code, sort of like a function or an object in other programming languages. And I will say that the documentation here gives you an idea. It shows you the roles folder, and then underneath that, there's a common role, a web tier role, a monitoring role, a foo app role, right? However, in your actual repository, you shouldn't really be storing roles in here, right? Your roles should actually have their own separate Git repository, which allows you to update and manage them separately from your playbooks. What should be in the roles folder here should be a requirements.yml file, which tells Ansible where to get the roles that you care about from. So the roles themselves will only be downloaded and installed, during runtime, and you don't really manage them in the top level playbook. It's not to say that you can't do that. But if you're going to be writing your own custom roles, it really behooves you to store them in their own Git repo because it allows you to better version them independently from your play repo. So really quick then, here's the alternative directory layout. The main difference between the alternative directory layout, which is a little bit more complicated than the simple one, is that instead of putting a productions and a staging inventory file at the top level, we actually have a folder at the top level called inventories. And underneath that, we have a folder for each of our data centers or areas that we want to manage. So we'll have a production folder and a staging folder. And then underneath that, we'll actually have a host file, which is now your inventory file for the production server under production and so on for hosts. And then we'll have our own set of group vars and host vars folders under that. The reason to do this is if your production and staging environments are so different that you don't really have a lot of variable reuse between the two, right? So in the simpler deployment or in the simpler repo example, those two inventory files at the top level, they probably have a lot of groups in common. They have a lot of variable reuse in common, which can be how your data center or your cloud is set up. But if you have very different and disparate, setups between production and staging or testing or whatever, you want to go this route because it allows you to have a lot of separation between the two and have completely different groups between the two. And it can be a little bit easier for you to manage. Everything else is exactly the same. So I've gone over how to organize your Ansible playbooks, and I alluded to the inventory file. And so I'm going to talk about the inventory file a little bit more just to give you some examples of what it looks like. So this is an inventory file. This is a flat file. This is actually the production file from the previous example that they're showing here. And as you can see, it's really a list of fully qualified domain names, could be IP addresses if you wanted, of the nodes that we're going to manage with Ansible. And in this case, this notation here is showing that we're creating a group in this file, and we're going to call it Atlanta Web Servers. And then these two nodes underneath that group are part of the Atlanta Web Servers group. So an inventory file not only tells us what nodes we're going to manage with Ansible, but it also allows us to group those nodes so that managing them is a little bit easier. You can see we have an Atlanta Web Servers group, a Boston Web Servers group, DB servers, and so on. But then we also are capable of doing groups of groups. Right, so the web servers group here is actually comprised of the nodes within the Atlanta Web Servers group and the Boston Web Servers group, and so on. And you can get very complicated with this if you like. I would suggest trying to keep it simple, but you can do whatever your needs are here to map groups to each other. And the reason to map groups to nodes is it allows us to assign variables to them. Like I mentioned, there's a group vars folder there, and we can assign variables to entire sets of nodes that way. And the one thing I didn't mention is that there is actually a catch-all default group that doesn't need to exist in your inventory file. It's always there in Ansible, and that is the all group. So if you were to put a all.yml file in group vars, that would allow you to create a set of default values for every node in your infrastructure, which is also very nice. It has less precedence than the other ones, so you can overwrite the values that are in there easier. Right. So that's inventory files, which brings us to, okay, so I know how to, design my repo, and I know how to set my nodes that I want to manage, but how do I actually run Ansible and do stuff against them? Well, one of the ways to run Ansible is to use it in an ad hoc manner. This is oftentimes very useful when you're debugging things, particularly if you're debugging your Ansible code itself, or if you're, trying to figure out why a server or service isn't doing what you expect it to. You can actually use Ansible ad hoc for debugging. Why is NGINX down? Can I just bounce it? Those kind of questions you can do with ad hoc commands instead of having to do them with playbooks. This is leaning a little bit more towards, the older CLI thing, but it is still a powerful tool that I have used a little bit. So some examples here, right? So in this case, we're running, there's two lines of code here. There's Ansible all-m ping-ubruce-b. So what is that doing? Well, that's running against every node in our infrastructure. That's what all is saying. And it's running the ping module. At the lowest level, all Ansible's really doing is running these different modules that it has, and I'll show you some examples of them in a second. And then the -U is telling Ansible to run as the Bruce user, so that remote node must have a Bruce user, and then it's telling Ansible to become. So in this case, that means we're probably sudoing to root, so we're becoming the root user on that node. The second one is showing you how to tweak, what user we're going to become. So we're going to start as the Bruce user and we'll become the Batman user. But there's lots of different command line switches available for ad hoc, as well as the playbook command. But real quick, I promised to show you some modules. So this is the complete list of all of the Ansible modules out there. There's quite a lot of them. They're fully supported by, Red Hat, which owns Ansible now. I like to show the file one because it's a simple one to understand. So if we look at the file module itself, you can see what we can do with it is we can change file ownership groups and permissions by using, this is the name of the module, and then these are options that we can pass to it. So in this case, we're looking at the etsy.foo.conf file, and we want to change its owner and group to foo and its mode to 0644, right? So what Ansible will do is it will look at this file, and if it needs to change the owner and group to foo or just the owner to foo, and if it needs to change the mode, it will do that for you, which is very nice. There's also a number of different things. You can create files or create symbolic links. You can touch files. You can, here's an example of looping through it. You can do very complicated things even with this basic module. And, there's like I said, there's tons and tons of modules here for managing all different kinds of things. And I would suggest that you first look and see if there's a module that exists for managing what you're trying to do. All right. It will save you a headache down the line instead of just using a shell command or a command. So that brings us to roles. Now, roles are really the way to manage infrastructure in Ansible. You can do things with tasks and modules, but roles are sort of the way of automatically loading a certain set of variables and tasks and handlers through a known file structure, right? It groups all that content together, kind of like a function or an object in a different programming language, and allows you to easily share and independently update that stuff. So an example I like to use here is, if I want to manage the NGINX service, I would try to find or write an NGINX role that allows me to do that. And that way I can keep it all packaged together in one location that I know about, and I can do things like, automatically handling the restarting of that service and so on. If you are going to write your own Ansible roles, I suggest that you use a tool called Molecule for doing so. If you've never used Molecule before, there's some great blog posts out there about it. I actually have a blog post coming out about it here, probably on Monday. So if you're interested, that will be available as well. Molecule really speeds up the creation and management, and it helps you with the management of developing your own roles. So roles are kind of the big thing here in the Ansible space. So, they expect to have files to be in certain directory names. You have to have at least one of these directories for a role to be considered a role, but you can exclude any ones that aren't being used. And when you have a directory, you oftentimes have to have a main.yml file in it, which has your relevant content, right? So underneath the role, you'll have a number of folders, whether or not you need them all. Like I said, you don't have to have them all, but you'll have folders like tasks, handlers, defaults, vars folder, files, templates, or meta folder. And underneath each of those, the names kind of give away their purpose, right? So the tasks folder would have a main.yml file under it. And in that main file, you would have a list of tasks that you're going to execute for the role. So in the NGINX role, for example, you would have a list of tasks for installing NGINX, for configuring it, and for possibly starting the service. that last one would probably fit better under a handler. So that's the next folder you could have, which is similar to tasks. It's simply a set of things to do if called. So you create something of a task in there, like for example, restart NGINX, and you tell it to listen for the restart NGINX term, and then in a task, if you call that handler, it will then restart the NGINX service at the end of the run. So it's a way of sort of creating a little reusable piece of code within the role itself. And it allows you to better control execution of things like restarting services and stuff, so that you're not doing it constantly throughout the role. It'll only run once at the end, regardless of how many times you've called it. Unless you don't want it to do that, there are ways around it, but that's its primary purpose. Defaults and vars folders, those are really your variables folders under here. Defaults are the default variables for the role, and the vars ones are another set of default variables for the role, the difference being variable precedence. So the default ones have less variable precedence than the vars ones, so they're easier to overwrite. So users of your role will be able to more easily overwrite them. Files and templates are similar. Files are files in which you want to deploy or manage with this role. So oftentimes they're ones that you'd be copying up to the remote node. So these could be things like configuration files if you want. They could be things like tarballs that are needed for an application and stuff like that. If you're going to do configuration files with a role, I suggest instead of using files that you make use of templates. Templates are Jinja 2 templates, which allow you to dynamically build out files, the contents of the files, as well as copying them up to the node. So that's where you would put those. So if I were to write an NGINX node and I was going to control how I configured NGINX, and in particular, NGINX is looking for an nginx.conf file somewhere, I would create a Jinja 2 conf file, throw it in the templates folder, and then copy that up. I'd put some variables in that file, and then I would set those variables with the defaults folder, right? And then finally, meta is simply, some meta information about the role. It's things like the name of the role, who wrote it, description, what it applies to, what type of systems it applies to. I would suggest before you go writing your own roles that you go and look at Ansible Galaxy and check to see if there are any roles out there that do what you want. It will save you a lot of time and headache. So I talked about how to design your playbook repo. I've talked a little bit about inventory, and I've shown you a little of the ad hoc commands, and I've even talked a little bit about roles, which are really the workhorses of Ansible. But you can't really do anything with roles or your inventory file without a playbook. So playbooks, really at the basic level, what playbooks do is they connect the set of nodes that you are going to manage with their roles. You can do other things in playbooks. You can run tasks directly in playbooks, and you can do very advanced things with them. You can do multi-tier rollouts, doing rolling updates and delegations to other hosts and all kinds of different things. But at a really basic level, the intention behind a playbook is to map a set of nodes to what they're doing, to what their role is, right? So these set of nodes are web servers, and they get the NGINX role, right? Playbooks, just like many things in Ansible, are expressed in YAML syntax, and there's a small amount of syntax and keywords. It's trying to avoid being a programming language or a script. It's mostly a model or a recipe, a step-by-step instruction process for the tool. Each playbook has one or more plays in a list. And plays are often, a set of tasks that are applied to a node, like I mentioned. And the goal of a play, like I said, is to map a group of hosts to some set of roles or some set of tasks, right? And like I said before, at a basic level, a task is really nothing more than a call to one of those Ansible modules that I showed. So what does a playbook look like? So in that example of the repository that I showed, we had a file called site.yml. And as I sort of alluded to, that file is going to define the configuration of our entire infrastructure. And this is a short example here because we're just going to import some other playbooks here. So in site.yml, we'll import the webservers.yml and the dbservers.yml playbooks. So if you were to run the site.yml file with Ansible playbook, it would then just run these next two playbooks in sequence, right? It would run webservers.yml first and then dbservers.yml next. And it would do whatever they're telling Ansible to do. So that brings us to, well, what are they doing, right? So in a file like webservers.yml, which is also at the top level of the repository, we are in this file, we're actually mapping the configuration of a node to the node, right? So we're mapping the configuration of the web servers group to the roles that are needed in order to turn it into web servers. So in this case, the webservers.yml file has a host line, and this host line is pointing to the web servers group. So that implies then that the inventory files at the top level also contain a web servers group, which have a list of nodes that we care about. And if you remember that example I showed you, there was a web servers group, which itself was a group of groups. And underneath that, we run two roles. We run a common role, which oftentimes are basic things that you want to run against every server in your infrastructure. Things like setting the time zone, stuff like that. Maybe configuring, your NTP server, right? Every node gets the same NTP server, possibly, that kind of stuff. And then your web tier role, which in this case would probably do something like configure and install NGINX, right? And turn it into a web server. And so the idea behind doing it this way, by having a site.yml file that calls other playbooks, is it gives you a lot more power over how you would run against your infrastructure. And that brings me to, well, how do I run these things? Well, the Ansible ad hoc command was Ansible space list of nodes space module to run. In this case, we call Ansible-playbook space the playbook we want to run. So in the first line here, you see site.yml. So we're going to run the site.yml playbook. And the command line option that we're passing here is a limit option. So we're only going to run the site.yml playbook against the web servers group. So if we wanted to, we'd run that. It would run through the web servers playbook, and it would also run through the DB servers playbook. But if there are no web servers in the DB servers group, which there shouldn't be, then it really isn't going to do anything with the DB servers. You might want to do this because you don't want to run against everything in your infrastructure. You only want to run against some a set. Maybe you want to run the common role against your set of web servers, and you don't want to deal with like just running the web servers role for one, or the web servers playbook for one reason or another. So it gives you a lot of different power about how you're able to run against your infrastructure. The second thing here could be analogous, where you're running Ansible playbook against the webservers.yml file. But that really depends on if there's anything else going on in any of your other playbooks. It's possible that you have a node that is across both DB servers and web servers. So you might run against it in the first case, but you might run against it in the second case. And then you'd run against it in the first case, and it would get some pickup from the dbservers.yml folder, or I'm sorry, playbook. So I have some more examples here. The ones that I showed you there were pretty basic, and there are some more complicated examples shown here. This is a public GitHub repo under the Ansible project. There's lots of different examples of different things that they are doing here. A simple one to show you is from the LAMP, simple LAMP being, a simple web stack. And this is a simple version of deploying it. And so in this case, they have a site.yml file. And what you're seeing here is you're seeing the ability to run against having multiple host lines, right? So we would first run this set, the common set, against all the hosts, and we would apply the common configuration to all those nodes, and we would try to connect via the root user here. And then the same thing, we would run against the web server's hosts now instead of all the hosts in the second case, and we'd run the web role. And then in the third case, we'd run against the DB servers and we'd run the DB role. This could be split up, like in our example, into 3 different files. It could be site.yml calling web servers and calling DB servers. Doing it this way of having an all here, you might actually want to put that in its own thing, because what will happen here is Ansible will reach out and connect to every node in your infrastructure, and it will try to do it simultaneously. So it'll be running against them all at the same time, and it will run the common role first against all of them. And then it will run disconnect from them and connect to all the web servers and run the web role and so on. And if you were to instead break this file out into 3 separate files with a site.yml file calling the web servers file and calling the DB servers file, and if you were to put the common role here in underneath this in the web file and underneath this in the DB file, what would happen is Ansible would not run the common role simultaneously against every node, right? It would first connect to the web servers folder or the web servers nodes and run common, and then web. And then it would run against the DB servers set of nodes and run common and then web. And so you might get some speed up doing it this way, or if you break it out into its own file, that is the common file, and then import that, you'd get some speed up there instead of breaking it out the other way. These are things you play with depending on the size of your environment that you're trying to manage. So here's another example. We didn't really go over this, but you can chain roles in an individual file, right? So this is a simple example of having multiple roles run. So in this case, we're looking to install WordPress, MySQL, Nginx, and PHP FPM. And in this case, we're running against every node in the infrastructure, which, depending on what your inventory file looks like, might not be the best idea. And then what we're doing here is we're chaining our roles together. So we have a list of the different roles that we're going to run in order, right? So Ansible will go through this list top to bottom. It'll run common first, MySQL, so on. Right. And so there are lots of different complicated examples in here. And some of them don't even make use of roles, which I like to kind of call out here. You don't have to use roles in a playbook. Roles are really great for reusable pieces of code, but if you don't need to reuse them for some reason or another, you can just run tasks at the top level. So this is an example of turning lights on and off with Philips Hue through Ansible. And you can kind of see we're even doing some IP address, or we're even doing some variable stuff here, where this is an example of an Ansible variable. And this is an example of a function being performed on an Ansible variable. So we might have, we'll grab a URI from, or we might have a variable called body info, and we'll turn it into JSON so that it fits in the URI module correctly, and so on. You can do some very, very complicated things with plays. So, right. So that kind of brings me to the last couple things to talk about. Ansible really fits well into a lot of different use cases. The one that I'm showing you is one that is sort of tailored around environments that might not change much, right? Those inventory files were flat files, right? Production and staging were flat files that you yourself as a person had to manage, which can be a little annoying. And then additionally, we didn't really talk about, well, where do I run Ansible from? I don't want my employees running Ansible from their laptops, right? Constantly to the infrastructure. It would be nice if there was a central place that we could do that. So one of the options for that is to use something like Ansible Tower or AWX. You do have to pay for Ansible or Ansible Tower. It's a Red Hat product. It's great for organizations that maybe want to centralize their Ansible runs. It allows you to, have role-based access control and scheduling, and there's an API to it, so nodes can come up and tell Ansible Tower that they're available and get their configuration that way, similar to how Puppet Master might work. There's a graphical interface and all that jazz. I've made use of AWX, the upstream open source thing, before. It's not exactly. I kind of prefer the other way of running it, by maybe having something like a CI/CD system kicking off automation for me. Ansible is flexible enough that it'll fit into kind of any of the use cases that you want. I alluded to that a little bit, but you can also, have Ansible generate gold images for you, right? So if you're using one of the HashiCorp tools like Vagrant or Packer, you can include some Ansible playbooks and Ansible roles in your Packer repository and build gold images in an automated manner as well. So you don't have to be like sort of stuck in one way of doing it. If you are going to manage like a big data center, then using like the repository or a big cloud infrastructure with Ansible, then using the repository layout, like I said, is really the best practice way of doing it. Which kind of brings me to what I mentioned a little bit, which was inventory, right? So the inventory files are static files. And if you're having constantly changing inventory, like in the cloud, that's not going to work for you, right? Infrastructure in the cloud doesn't always have the same thing from 1 minute to the next. You might not have the same set of nodes from 1 minute to the next. And so managing that flat file yourself manually is a nightmare. And that's where things like dynamic inventory come in play. Dynamic inventory are really like Python or other scripts that integrate with an API of some kind. So the example that they use often is the AWS API. So you give Ansible some AWS credentials, and it can pull information about your current inventory right before it's run, possibly even getting groups. So one of the ways of doing that would be to like tag your inventory and pull from the tags, and that would give you your groups. And that is a way of dealing with inventory in a cloud manner in which it's changing constantly. There's lots of other ones. There's, Azure ones. There's things for pulling from things like Cobbler and CMDB software and stuff. So it can make dealing with your changing inventory a little bit easier, which is always a good thing. So about on time, which is good for me. So if you have any questions, here's my contact information. And then I think, Shane, I was, do we have any?
Yeah, one question I had, Matt, and you could touch upon is how would Ansible work in a cloud environment, if it would, and what recommendations do you have? Right.
So Ansible works pretty well in a cloud environment because it's very flexible. So what I sort of briefly talked about was using the HashiCorp tools, right? So HashiCorp Packer is a tool for generating gold images, and you could generate, and those are, sort of like an image that you might use to constantly redeploy your servers or services from, right? It's my pristine standard image. You could use Packer to create things like an AWS AMI image. And so Ansible could be called by Packer to pre-configure that image, right? So let's say I want to make it so that when I deploy an NGINX server, in AWS, I always do it from this gold image. Well, you can have Packer periodically rebuild that image. And what Packer is actually doing is it's calling Ansible to install NGINX and pre-configure it. And then at runtime, you could use Ansible to, inject some runtime variables to configure that image. Additionally, you could use something like dynamic inventory to talk to the AWS API or Azure API, or any of them, and get a list of what your nodes are out there that you need to manage, and you can then configure them that way, in the older way, or not older way, but in the at runtime way, instead of creating a gold image. And then finally, Ansible itself actually does have the ability to speak to the AWS or Azure API to manage things as well. That in that list of modules that I showed, if you were to look through it, there is some AWS modules in there. So you could use Ansible to provision stuff in AWS. I am of the mind of not doing that, just because of what I alluded to earlier, which is, Ansible really wasn't initially designed around that use case, and Terraform and CloudFormation and the tools that were seem to do a little bit of a better job at that. It's not to say that you can't do it. It's just not the way I would do it. So yeah, there's a lot of different ways that you can leverage Ansible in a cloud native world, because of how flexible the tool is.
Great, thanks for that. That was the only one in the queue, but I'm going to leave you with one more, Matt, and we can wrap on this. Is the SEI is always looking to hire. Maybe talk a little bit about your experience here at the SEI. I know you've been on a couple of different teams over the years, and you've been able to grow in your career. What keeps you at the SEI?
Well, the work is interesting, and it's really flexible as well. I have a family, a couple of young kids and stuff, and so it's very flexible here. Like I mentioned, the work's really interesting. I work for a lot of really cool different government organizations, and it's been fresh, like you said. I've been on a bunch of different teams here. I've done a lot of different things at the SEI. Actually started as an intern. And I did some research on web vulnerabilities for the Network Situational Awareness group at the time. I transitioned to doing vol disclosure, which was very big about 10 years ago here. We used to help large organizations deal with vulnerability disclosure stuff. And then I've did some network situational analysis as well. I actually used to teach at FlowCon. I taught the Silk course at FlowCon, which is the SEI's NetFlow analysis tool. And then I transitioned over to helping manage a lab, a data center in DC for a government organization, and got involved in doing a lot of the DevOps stuff and big data stuff. So there's always something new and interesting, and that's why I'm still here.
I appreciate you sharing that with us, Matt, and thank you for the great discussion, and especially sharing your expertise.
Thank you.
And we'd like to thank you all for attending today. Upon exiting, we ask that you hit the like button below the video window and share the archive if you found value. Also, you can subscribe to the SEI's YouTube channel by clicking on the SEI seal in the lower right corner of the video window. Any questions from today's event, please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.